Math. 19.1, day number 3, vectors. Those of you following on the web, good for you. Getting a little extra math gains in. We're going to represent vectors in 2 dimensions and 3 dimensions today. We're going to talk about the unit vector representation. We're going to add, subtract, and scalar multiply. Just as a, I think we talked a little bit about this yesterday. I can't remember because I can't remember what I did for the most part yesterday. But if I have vector A and I scale it by a factor of 3, will the magnitude get larger or smaller? Larger. What happens to the direction? Does it change? No. What would happen if I did this to my vector A? It would change direction and do what? Yeah, shrink by a factor of 1/3, right? So negative scalars change the direction. If the scalar on the front is larger than 1, it will change the magnitude, making it larger. If it's between 0 and 1, it will make it smaller. Ah, yes. That's scalars. Let's move on. Okay, really cool practice problem here. I'm going to do part A. I'm going to leave B and C to you and your own curiosity. But let's draw vectors OC and OD. Here's vector OC. And here's vector OD. If I want to go from point C to point D, that's vector CD. How could I represent that using OC and OD? Well, I take my little person here, probably someone cool like Walter Payton or Mike Ditka. Definitely not Fran Tarkenton. Okay? I'd take my my person there, and I'd travel them along the known vectors that I'm supposed to represent. So I'd go this way. Is this OC? No. Yeah, that's negative OC. Is this OD? Yeah, that's OD. So that would be a representation of CD in terms of OC and OD. Someone last hour said, couldn't you just write it like this? The answer to that would be what? No, because this right here is not OC. You have to write it in terms of OC and OD. Okay, so this would be no good. Scratch that, child. Okay, let's keep moving to the new materials. Okay, here we are for the new material. I'm just going to jump right in. That's what I'm going to do. All right, so here we have vector A. This is vector A. Vector A I can write in 2 different forms. I could write in position form, position vector form, or I could write in column vector form. Sometimes I like to call this position vector form component form. You'll see why in a second. I sometimes call that component form. All that vector A is doing is it's traveling to the right or to the left and then up or down. All right, so how many units does vector A travel to the right? 4? 5? 5 units to the right, so that'd be 5i in position vector form. I represents the horizontal movement. So it'd be 5i plus 3j. Okay, in column form, I prefer column form personally. It's less writing. Column form is a matrix. Oh, back to matrices. All it is horizontal movement, vertical movement. Awesome. Now, could I find the magnitude of this vector? Yeah, I'd use Pythagorean theorem. All right, I got a 5, I got a 3. So the magnitude of vector A would be the square root of 5 squared plus 3 squared. So the magnitude of vector A would be, what is that, square root of 34? Okay, that would be the magnitude of vector A. Okay, I want to touch just briefly on this idea of a identity vector, a unit vector. We also call it the identity vector. What would be the magnitude of this vector? 1. What would be the magnitude of this vector? 1. What would be the magnitude of this vector? 1. Wait a minute. What? What? Hold on now. Let's say vector B is square root of 2 over 2I plus square root of 2 over 2j. Wait a minute. Okay, if I go from the origin and I go right root 2 over 2 and up root 2 over 2, what's the magnitude? 1. That's a unit vector, a vector with magnitude 1. Oh, you know what's cool? There's a lot of those that exist. How about this one? 1/2 negative root 3 over 2. Is that a unit vector? Yeah, it is. So if I had vector C and it was this, you know that's a unit vector.
No, he's kidding.
Okay, so vectors not only are two-dimensional, but they can go three-dimensional, folks. Three-dimensional vectors. So we just looked at two-dimensional components, right? This is all fancy jargon for there you go. There's your horizontal movement, vertical movement. What happens if I throw a third dimension in there? Then if we have 3 dimensions, this would become xi, right? Horizontal movement times I, plus vertical movement times j, plus movement toward or away times k. This is fun three-dimensional stuff, Liam. Oh, it's fun. Now, I could write this in the column vector form as x, y, z, right? That's just another way to rewrite that. So let's do some of this. Okay, so here's 2 vectors, A and B. All right, so let's analyze A for a moment. How many units does A move to the right? 4, okay? So the direction vector for A would be 4 and then 3. All right, if I preferred component form, I could say 4I plus 3j. Those would be good. I can do either. Either one works for me. Okay, for vector B, what's different about vector B? Goes left, -5, and then up 5, right? Either form, vector in column form or vector in component form will work. Yep, good point. Had someone catch this? That should be xi and yj. Thank you, sir. Okay, so then comes vector addition and subtraction and scalar multiplication. Very, very straightforward. Okay, if I add A and B together, right? If I add vector A, which is 4, 3, to vector B, which is -5, 5, I just add like components. What's 4 plus -5? -1. And 3 plus 5? That's 8. So if I combine those 2 vectors together, going A plus B, so that would be A, and then B's tail to A's head, and from there, we'd go tail to head, and we'd get 1 unit left and 8 units up. Okay, I'm going to skip part B for a moment. I'm going to go to part C. What would 2A equal? Well, I'd scale A by a factor of 2. So what would 4 become? 8. What would 3 become? 6. Good. So I get 8, 6. And if I take said vector over here times 1/2, I get -5 halves. -5 halves. No, sorry. +5 halves. -5 halves. Okay. So I distribute this -0.5 to both the parts of B, and I add them together. That to me looks like 21 halves. And what would that be? 12 halves minus 5 halves would be 7 halves. All right, some child's going to say this. Is this okay, Mr. Ludd? Could I write 21 halves I plus 7 halves j? Sure you can. Could I write 10.5 I plus 3.5 j? Sure you can. This is not very elegant, but technically it's true. All right, let's keep rolling. No way. That's the end? All right, I want to look at maybe a homework problem here. All right. All right. Hold on. Here we go. Ooh, this is a good one. I want to look at number 8. Find the values of A and B if this minus this equals this. So how would I write that? I'd go here. I'd do this. See how I get that from the first one? I go from the position form to the column form. Minus 3 times 3 negative 1 and B equals negative 37, negative 25, and 5. So what I would do, folks, is this. Why did I do that? What does that mean? That means 7a, oops, I want a capital A so I don't confuse myself. 7a minus what? 9 equals what? Negative 37. Oh, easy. That means 7a equals negative 28. The Bears hit all of their extra points ever. So I know that that means 4 touchdowns, negative 4 touchdowns. No, Vikings, negative 4 touchdowns. Yeah, Vikings. So I can figure out A right away. Done. How could I figure out B? That's a negative 4. Yeah, that's a negative 4. I got to go 4A, right? Isolate B. Well, I know A. A is negative 4. So what does that tell me? That tells me negative 4 times 4. Negative 16 minus what? 3B equals 5. Aw. Just the 7s are coming out to play. Yeah? Aw. What does B equal? Negative 7. Boing. All right, so that I don't totally mentally just make you folks on the web just scared. I'm going to erase this as I record. Because otherwise you'd be like, where'd the answer go? There, it's gone. Okay. 2 vectors are defined as the following. A is that, B is that. Find the values of scalars x and y. Okay, I can do that. Hi. That's this. Yeah. Oh, yeah. There's more numbers. Oh, yeah. Okay. I'm good at algebra. So here's what that says. See if you can stick with me. Negative 3x. I'm working in the upper component. Plus what? 6y equals what? Negative 36. Oh, okay. Then in the middle component, your vertical movement, up or down, I have x minus 6y equals 32. Oh my goodness. Process of elimination. What would go away if I added both of these? Not all of them. That would be scary. Yeah, these go show. Kind of like the Twins relief staff. They just go meow. That leaves a negative 2x equals negative 4. Easy. You can use I and J, but it's scary. I like vector column form. So now x equals 2. What could I do now? Yeah, plug it in. Let's plug it in here. Negative 3 times x plus 6y equals negative 36, and then I just math it. Oh, this is fun. I know how to math this. Meow.